Plug in 0, so 0 plus 1 is positive. 0 minus 3 is negative. 0 does not live where I'm putting them, sorry. Negative, and positive. So overall, what is that region? Negative. Again, no multiplicity. Are we good on that? I say it every time, but do you guys know what I mean? Or okay, like some of you are like, I don't know. It says it. If it had been like x plus 1 quantity squared, that would be multiplicity, and then my number line would behave differently. It's like with the polynomials, it would bounce there. So if it was negative, it'd stay negative. We don't have that. We don't have any multiplicity. There's no quantity raised to some exponent, okay? All right. So since I don't have multiplicity, this will alternate nicely. So I want the positive parts, because I want to take the square root of the positive. So the negative 6, the negative 1, and the 3, what's not included? Yeah, negative 6. But the negative 1 and the 3 are. So your answer is parentheses, negative 6, negative 1's bracket, and then bracket 3 to infinity. Do we feel a little bit better about those now? Okay. All right. Any questions on anything before we move on to 2-3? The homework, I'll get the second attempt on 2-2 assigned to you soon. I know a few people need to do that. So. Okay, then let's go ahead and start. All right, guys, your 2-3 notes. Okay, we're going to start with graphing rationals. We've talked about this a little bit, like we've kind of touched on a few things. We talked about the asymptotes with the quizzes and a review, but we're going to go through like all the pieces of it and how you go about graphing rational, okay? So few things, some characteristics that you want to pay attention to when you are graphing rationals. First is you might have a hole. Okay? And that happens when there's a common factor of the numerator and denominator. So with your rational, if you get it in factored form and a factor cancels out of both, that creates a hole. Okay. All right, then we have vertical asymptotes. You find this by setting the denominator equal to 0. Usually you're going to factor and then set your factor from your denominator. I think those you guys are pretty good at. It's the horizontal asymptotes that we kind of mix up every once in a while. So do those next. Okay, a few things that can happen here. There's 3 different situations. We can have balanced, or sometimes call it equal. And that's when the degree of the numerator equals the degree of the denominator. And the way you find your asymptote then is you say y equals the leading coefficient of your numerator divided by leading coefficient of your denominator. And we'll do examples with all of these. We'll just get the rules written down first. Okay, next we could have what is considered bottom heavy. And that just means the degree of the denominator is greater than the degree of the numerator. And anytime that happens, when it's bottom heavy, your horizontal asymptote is always just y equals 0. So we've done equal degree, bigger degree on the denominator. The other option is the bigger degrees on the numerator. Technically, that's not a horizontal asymptote. It's called a slant asymptote. So again, that's top heavy. So that's degree of numerator is greater than degree of denominator. And you find this with long or synthetic division. So there's a reason we review that before we get to graphing rationals. All right, then two other things that are important when you're graphing your rational, finding your x-intercept. And I think you know this, but it's good to write down. It's when y equals 0. And the way you find that, find by setting the numerator equal to 0, okay? That's the only way that y can equal 0 is if the numerator is equal to 0. And think about your ordered pair. It's going to be some x value, comma, 0. So then the last thing we'll want to make sure we find is the y-intercept. And that is when x equals 0. And you can just plug that in. So plug 0 for x. And your ordered pair there would be 0, comma, something. Guys, any questions so far on just like everything you have to show in the graph? We're going to do a bunch of graphs. All right, so let's try one. So our function is x minus 3 over x plus 4. So we're going to sketch the graph. I'm also going to list over here on the side like all the pieces that we have to find, like the things we need to run through to see if they exist. So first, what do you think? Is there a hole in this one? No. I'm just going to write none. There's no common factor between the numerator and denominator, so no hole. All right, vertical asymptote. I'll just do abbreviations for all of these. What do you think? Is there a vertical asymptote? At what? Sorry. -4, yeah. And is it x equals -4, y equals -4? Good, yeah. Vertical asymptote, those are always the x equals. So x equals -4. Again, that's just your denominator being set equal to 0. Just go 1, 2, 3, 4. They're all little vertical asymptote. It's almost vertical. Okay, do you think we have a horizontal asymptote or a slant asymptote? You can never have both of those, so horizontal, and what's it going to be? Y equals 1, good. All right, let's find our intercept. So let's think about the x-intercept first. Okay, remember the x-intercept is when y equals 0, and the only way y can equal 0 is when the numerator is equal to 0. So what do you think, guys? What is your x-intercept? 3, 0. Yeah, good. If you have multiple factors in your numerator, you're going to have multiple x-intercepts. Okay. All right, so we got a point over here at 3, 0. And then let's find our y-intercept. Remember, that's where we plug 0 in for x. So what do we get? Good, -3, 4. So I'll put a tick mark at -1, and then I'll just put a dot, you know, pretty close to it. Obviously, I am not looking for perfection on these graphs. I'm not going to look at that and say, oh, you plotted that at -2/3, not -3/4. Yeah, like, you're in between the right two integers, we're good. Okay? All right. If you want, you could plug in one more point. Like, we definitely have enough to see what's going on the right side of the asymptote, right? You guys, can you tell, like, it's going to follow the shape? is probably going to be up here, but if you're like, I'm not quite sure, you can always just plug in one x value on the other side of your asymptote. So we could check, we could plug in like a -5. And even just look for the sign of that. So if you want to find one point. So what do I get if I plug in -5?
Positive.
Positive 8, good, yeah. So that's somewhere up here. I'm not even going to put tick marks. I don't know. It's over there somewhere. That looks like 8, 4. The whole point is so that I know like which asymptotes to be in between. So I now have plenty of information here where I can sketch my graph. Your graph will follow your asymptotes. So it's going to go like this and like that. Now that was a pretty basic, straightforward rational, but the steps are going to be pretty much the same no matter what it looks like. So do you understand the process there? Not too bad. If I asked you the domain of this, could you tell me? What do you think? Never mind. Okay. Anybody think they know the domain? Yeah.
Negative infinity, -4, parentheses, parentheses, -4 infinity.
Perfect. Yeah. If I asked you domain -infinity to -4, but we're skipping over that, and then -4 to infinity. So something to note with asymptotes that I'm not sure is always made clear to you guys. The vertical asymptote, your graph will never touch the vertical asymptote. It cannot cross that value. That value is not a part of the domain. The horizontal asymptote, your graph absolutely can cross that. The point of the horizontal asymptote is to tell you what happens at the ends of your graph. So you could have, you don't need to draw this, but you could have a graph that's got like vertical asymptote, horizontal, something over here, and then that guy in the middle could completely cross through the horizontal asymptote. It's in the middle of the graph that has nothing to do with the ends, so that's why you can cross it. Okay? Am I right that that's not really something? Are you guys just like, no, an asymptote is an asymptote, we can't touch it? Okay.
Well, only for like situations.
Yeah. The important part with the horizontal asymptote is what's happening out here and out here. Okay? All right, let's try another one. Let's do y equals, I'll give it to you already factored, x plus 3 times x minus 1 over x minus 1 times x plus 1. Do you guys want to try this one? Sure. Is it the weather that's making you guys tired today? Oh, okay. Wow. That's fair. Okay, thanks. So just go through all of these pieces. Is there a hole? So where is it? Vertical, horizontal, x-intercept, y-intercept. Just find your pieces and slowly build your graph, okay?
Oh, no, that's cool.
You cancel it out, and then you're really looking to crash for the X part's easy. You have to find the Y part. Does anybody know how to find the Y part of your hole? Plug it into what's left. Like you've canceled out those two factors, plug it into the remaining factors, and then you'll get your Y done. Okay.
No, when you have cold, you just cancel it out.
Yeah, so you're really just looking at grabbing this. Yeah, it's easier. You can't really have the acetone like.
Yeah.
Yeah. Okay, can you find the Y part of the hole? Okay, so you're gonna go to the 0.12 and just draw a little. Give you guys another couple of minutes. Check with your neighbor. Pretty heavy sky over here. We're doing okay?
Yeah, I feel like 0.6.
All right, guys, let's go through it together and just see how you did. So I think we're okay with the x minus 1 cancels, and we know that creates a hole. And so the x part of the hole is 1. Everybody's okay with that, right? What is left is this y equals x plus 3 over x plus 1. That's really the function you're now doing everything from. Okay, because we've canceled out that hole. So if I want to find the y part of the hole, I just plug it in to what's left. So 3 plus 1 is 4, 1 plus 1 is 2, so we've got this hole at the point 1, 2. Now what you do with that on your graph, you're actually going to go to the point 1, 2 and draw a little open circle. Okay, you want to note, hey, there's a hole on my graph here. Okay, then vertical asymptote, that's when the denominator equals 0. So again, that's going to be at x equals negative 1. So we can go over here. And remember, I'm doing everything from this guy now down here. So the horizontal asymptote, I can see the degrees are equal, so it's going to be y equals 1 again. Okay. X-intercept. That is when y is 0, and the only way that can happen is when your numerator is 0. So negative 3, 0 is your x-intercept. To get your y-intercept, you plug 0 in, and you would get 3. Okay, and I don't even really want to plug in another point. I think I have enough to graph this. Because the hole actually helps guide your graph too. It's not like your graph is over here and you just randomly have a hole down here, okay? Like it's all got to follow the same shape. So you would follow the asymptotes. There's one part. And there's the other part. How'd we do? Good? Are we okay? Getting there, guys? All right. Let's try another one. Okay, let's do y equals 2x squared plus 3x minus 5 over x plus 4. We'll go through this one together, guys. So when I give you a function like this and it's not factored, the first thing you're going to want to do is factor it if it factors. So denominator's fine as x plus 4. I'll give you guys a second. Factor your numerator for me and let's see what you get. What does it factor into, guys?
2x plus 5, x plus 1.
2x plus 5, x minus 1. That looks good to me. Okay, so if I go through my list, hole, we don't have a hole this time. Do I have a vertical asymptote? Yes. Where is my vertical asymptote?
-4.
Okay, and what equals -4?
Okay.
Okay, good. All right, do I have a horizontal asymptote or a slant asymptote? I have a slant this time, yes. Sometimes you'll hear them called oblique asymptotes. The same thing as a slant asymptote. Okay, we haven't done one of these yet. Initially I said we have to find it by using long or synthetic division. So what do you guys want to do? Long or synthetic? Synthetic. It'll work this time. So yeah, let's do synthetic. So I'll put the -4 out here. You write the coefficients, then I'll move this up a little. 2, 3, 5. So I'll just go through the division, bring down the 2, -8, -5, 20, 15. Okay, so this is 2x minus 5, and then we have this lovely remainder of 15. Okay, we don't care about the remainder when we're doing the asymptotes. It's not that it doesn't matter at all, but it's just so small that it's not going to impact what the graph looks like. Okay, so my slant asymptote is just y equals 2x minus 5. You can just ignore the remainder. Okay, how do you graph y equals 2x minus 5? -5. Yep, exactly. Yeah, guys, y equals mx plus b. Remember this from long ago. Start at -5. 1, 2, 3, 4, 5. And then my slope is up to 4, 1. And again, this is an asymptote, so just dash. Hopefully yours is a little straighter than mine. Got a little curve to it. And then we just need our 2 intercepts, so I need my x-intercepts, or there's multiple this time, and my y-intercept. Will there ever be multiple y-intercepts? No, right? Wouldn't be a function then if you had 2 y-intercepts. So you can have multiple x-intercepts, but only 1 y-intercept. So what are my 2 x-intercepts?
1 and -5.
Good. So 1, 0, and -5 halves, 0. So I'll plot those guys. So 1, 0. So -5 halves, that's just -2.5. All right, and then what is my y-intercept going to be? And sometimes that's easier to go back to the original function and look at. Right, if I plug 0 in there, that's a little easier than 0 in the factory. 5/4. Good. So that's somewhere in here. Okay, we have enough to sketch our graph. So let me scroll down so we can see it. I'm going to erase my my synthetic division here because I didn't leave myself enough room for this graph because it's kind of big. So let me extend my asymptotes a bit here. got giant, I'm not sure. Okay, I've got these 3 dots, and maybe I'll make it blue so we can see them a little better. I've got my 2 x-intercepts and my y-intercept up here, so I can tell, well, it's got to be kind of following this shape a little bit. So where is the other part of the graph going to be? Is it going to be over here? Is it going to be over here? No, down here? Yeah, okay. If you want, you can of course plug a point in on the left side of that vertical asymptote, so plug in like a -5. But I know it has to be somewhere down here. And again, not looking for perfection, just going, okay, it follows the asymptotes. Just looking for general shape in the right part of the asymptotes, okay? Questions on that one? Okay. Let me give you, we're going to practice a couple here together. All right, let's try this one. So we can keep it as part of your notes, but we're just going to practice a few here together. Let's do y equals x squared minus 1 over x. Okay, I want you guys to try to graph that. So work with your neighbor on this one. Chat with each other, think through what you need. Yes. Oh. Zach? Does that slant asymptote or horizontal? Slant. Okay. So, yep, good. So, like, you could go through, like, if you wanted to. Like, what is the 0 root of? Like, we're used to seeing a factor like x minus 1 down. This one's just x, so what do you decide to smash? Okay, so like in the one we did, go back to it. So like on this one, what did I do synthetic division with? Okay, because that's what made the denominator 0, right? What makes your denominator 0? Okay. It's like, it's too easy to see it here.
Yeah.
So if you're divided by 1, it'd be like x times 1.
Oh.
Yep.
There is no. Just write them in. Well, you can't intercept the x axis. Actually, that's
I got it.
oh, yeah. So it's just like one over one.
I'm not like
I'm just
my brain has those conversations.
and I don't know if I want to understand it.
Well, there wouldn't be a y intersection because the vertical asymptote is x equals 0.
Like you're not that far off. Just sort of right? So
What is
That's sort of the area.
Oh, all I have is this. These 2 points back.
Like across like this. You probably shouldn't do that.
I thought it was undefined. Isn't it like straight up and down? It's something like that.
Or it should be straight horizontal.
I really don't know.
Like the other side. So scribble this out.
right. Fall.
No, that's wrong.
Yeah.
I know it's lost.
What's actually X minus?
Yeah, I don't. Yeah.
You can't.
That minus one is over here.
I'm smart.
So
See, there's
Oh,
something.
you're so smart.
Oh wait, no, that no. It's 0 X, right?
Oh, gotcha. I did it all.
Wait, but it doesn't.
Oh,
Michael's next.
But you couldn't divide anything by 0.
So it's the same right here. My dog. That should be
Like in that one, I wasn't dividing by negative.
this one.
Okay. But the y intercept.
Yeah,
I think it's from 0.
Oh, that's correct. I drew like all of them in different spots. For some reason, when I wanted to do that, so.
It's sort of like
Well, yeah,
Find it.
the last person next to me.
okay, we get there. I haven't decided. All right, guys, let's go through it. Okay. So we can factor. All right, we don't have any poles in this one. We do have a vertical asymptote at x equals 0. All right, guys, the slant asymptote. You have to do division. Now, I know it feels weird to write a 0 out here. You're not actually dividing by 0. You're dividing by x, but when you do the synthetic division, you write a 0 out in front. Okay, so it's not that you're dividing by 0. That's just how we have to write our coefficients. And then don't forget that there's a 0 that you need as a placeholder. And then there's just lots of 1s and 0s here. Okay. The -1 is the remainder, so I do not care about it. This is really just y equals x. This doesn't matter. So that's my slant asymptote. So I've got a vertical asymptote here, and then a slant asymptote here. Okay, the x-intercepts, there are 2 of them because there's 2 factors in the numerator. So we end up with 1, 0, and -1, 0. Do I have a y-intercept? No. Because if you plug 0 in for x, you divide by 0. That's no good. So there is no y-intercept, which makes sense. Your vertical asymptote is right on the y-axis, okay? This is enough. I know where the graph is going to be, so I can just say, okay, and it follows my asymptotes. And that's it. Okay? We feeling okay with this? Let's see. Do we want to do one more? Yes, please. One more. Not that one. Let's see. All right, let's try last one, guys. So let's do 5 over x squared minus 2x minus 3. Okay, try that one. Yes. Everybody made it down. Sean, will you put your phone away, please?
Yeah, I'm pretty sure.
Yeah, and I think
No, no,
that
I'm not. Oh.
I'll let you.
Yeah, of course they're gonna.
Multiply them. Oh, you're right. So it's five. Yeah.
Yeah, so the other, it's gonna be one of them, the ones where it's like, here, and this one goes through. But I don't know if it's like maybe positive. I think it's going negative. But I feel like if I go to the bigger, it's like one, so there's like, Or maybe like.
Guys, you do have to plug in some values this time to get some points, but do we really care about the exact y value? No. What do you think is going to matter with the y value? Like, what's going to help us?
If it's a positive or negative.
Yeah, it just is it positive or negative? If it's positive, it's above that horizontal axis, but if it's negative, it's below. So don't drive yourself nuts figuring out like the crazy fractions. Just try to plug in a few things.
Better. I plugged in, I plugged in 1, and then 18 and then 5, 6, so that's, so then it's applicable. Or if I plugged in 1, then 5, and then why can't I do like?
So plugging in, you can plug into the original. You could even plug into the factored part, and then it's kind of a lot like when we do our number line test. Like I'm hearing some people plugging in numbers and really their brains are clearly hurting with the adding and subtracting. Not just you. You're not alone, I promise. So like I would look at this. Let's say I plug in, I don't know, 4. So plug in a 4. I have a positive 5. 4 minus 3 would be a positive. 4 plus 1 would be a positive. So when I'm over here at 5, it's somewhere up here, right? Are you with me? Okay. What if I plug in, I don't know, 1, something in the middle here? That's going to be a positive 5. 1 minus 3 would be negative. 1 plus 1 would be positive. So plugging in 1 gets me some value down here. If you're still unsure, the middle part is always, I think, the hardest part to recognize. Is it like some sort of parabola or is it like a cubic shape in there? Plug the 2 in as well and see what you get. Positive, you can see it's still going to be negative. Positive. So overall, still negative. So this middle section is doing something along those lines. Again, not looking for perfection here, just general shape. And same with the right side. If you're like, well, I don't know, I plugged in 4, not sure, let me plug in 5. 5 again is going to get you a positive value. So this part should be somewhere up here. And then I still need way on the left. That would require me to plug in like a negative 2. 5 is positive. Negative 2 minus 3 would be negative. Negative 2 plus 1 is negative. So overall, do you again see how that's positive and I'm somewhere up here? Yeah? I don't need the exact point. I'm not going to ask you, like on a free response part of this, I'm not going to say plot exactly 9 values for me or anything like that. I just want, hey, I got the asymptotes, intercepts if they exist, shapes going the right direction. That's it. Okay. Anybody questions on what I'm doing with these pluses and minuses? Is anybody looking at that just going like, what in the world? Why are there so many pluses and minuses? Yeah? Yeah, because again, I don't really care. Like, if I plug in 4, I don't care if it's 4, 2, or 4, 5, 7s, or, you know, I just care, is it positive or is it negative? Like, I need to know where's the shape of this graph. So when I plug a 4 in, I'm just using the factored one because that's easiest for me. You could plug it in here, absolutely, you know, if you want the exact value, but since I really only care about positive or negative, I'm just plugging it into the factored one. Okay. Good? We all right? Okay, you've got about 10 minutes left. I did make your math space, the 2-3 homework available to you, so you can start on that. Let me get your second attempt ready.